Hi everyone. In this class, we are going to learn about surface areas and volumes, full concept. In that first, we'll discuss about cube. We know that in cube, all faces are equal area. In cube, all faces will be equal. For example, if you see this is the front face and its opposite back face, everything same. Cube means all sides will be equal, so all six faces consisting equal area. So each face area will be a square, a square, a square. It is also a square. So totally six faces we have. All the total six faces is consisting a square. So the total surface area of cube, of TSA, TSA of cube, total surface area of cube will be 6a square. And lateral surface area LSA. LSA is nothing but total surface area minus area of base, like the base floor, plus top area of the top face. So this is nothing but 6a square minus the 2a square will get 4a square, and volume of cube. So all the three dimensionally this should be equal. So A will get A cube, and diagonal will be root over A square plus A square plus A square. It is nothing but root 3 into A units. Area is always square units and volume is cubic units, and diagonal is units. If they given centimeter, centimeter, meter means meter. Okay. The next one, we'll go with cuboid. In cuboid, it is the front face. The front face area and its back face area will be same. And top and bottom will be same. And it's the right side face, and its opposite left side will is also same. Now here, total surface area. See, if I consider this is length L, breadth, height LBH. Now the total surface area. The front face is LH, correct? So LH and back side also LH. So 2LH plus the floor is LB. So top is also LB, 2LB, and the right side is BH. So left side is also BH, 2BH. So if you take 2 will be common, we'll get LB. So if I written in order, LB plus BH plus HL. This is total surface area of the cuboid. And what is LSA? We need to remove in this total surface area of the floor and area of the ceiling like a top. So TSA minus, that is 2LB. So if I remove total TSA 2LB, we'll get 2BH 2BH plus 2LH. In this, if we take the common, 2H will be common. We'll get L plus B. This is lateral surface area of the cuboid. Sometimes they will ask, find area of four walls. Area of four walls. So area of four walls is nothing but LSA only, lateral surface area, the area which formed by using the sides. Next, volume. Volume of cuboid is length into breadth into height. Then diagonal of cuboid will be root over L square plus B square plus h square. So already I said no. Area is square units, volume will be cubic units. The next one, cylinder. In this cylinder, see the given already. This is a radius, height, and it is a curved surface area, circular base. The both ends we have the circular base. In this CSA of cylinder. Cylinder is like a prism shaped figure. So CSA is nothing but perimeter of the base, perimeter of base into height. The base will be circle shape. Circle perimeter is 2 pi r into h. So it is the CSA of cylinder. And TSA is nothing but CSA plus 2 into area of base. Area of base. So CSA will be 2 pi r h plus it is 2 pi r square, area of circle pi r square. If I take 2 pi r common, we'll get h plus r. This is total surface area of cylinder. Then volume. Volume is nothing but area of base into height. Area of base into height. So what we get? Pi r square into height will be h. So volume of cylinder is pi r square h. Next, we'll move on to the cone. So here, this is the radius of the cone and it is height of the cone h, radius r, and this is slant height. Slant height. Just observe this figure. OAB is a right triangle. Correct? Now, in this, what is the relation between L, H, R? Relation between these three? L square is equal to R square plus H square. L square is equal, like the hypotenuse square is equal to side square plus side square. So L square is equal to R square plus H square. Then here CSA of cone is pi r L, and TSA, total surface area, CSA plus base area, plus base area. So CSA is pi r L plus base area is pi r square. If I take pi r common, we'll get L plus R. This is the total surface area of cone. Next, volume. Volume of cone. Volume is nothing but 1/3 of cylinder volume. Cylinder volume is pi r square h. Cylinder volume is pi r square h. Next, sphere. Sphere. So it is a radius and its height is nothing but diameter. That is here r and here r. So the sphere can be divided into 4 equal area circles. So that's why a sphere we don't have any base or any top surface. So we have only surface area. The surface area of the sphere. Surface area will be 4 pi r square. 4 pi r because this entire sphere will be divided into 4 equal area of circles. 4 equal area of circle. So each circle area will be pi r square. So surface area of the sphere is 4 pi r square. Then volume. Volume is equal to 4 by 3 pi r cube. 4 by 3 pi r cube. Next, hemisphere. It is the hemisphere. Radius r and height of the hemisphere will be radius only. Here we have a one either base or top face. So we have CSA and TSA. So CSA curved surface area is equal to 2 pi r square, exactly half of sphere, 2 pi r square. And TSA means the total surface area. So CSA plus base area, base area. So we'll get it is 2 pi r square plus it is 1 pi r square. So totally we'll get 3 pi r square. Then volume. Volume is equal to 2 by 3 pi r cube. 2 by 3 pi r cube. So this is the total concept of the total concept of surface areas and volumes and their formulas. And we'll see some combination of figures. They will ask the questions this type of combinations. See here, it is a cylinder with a combination of two hemispherical ends. Now, how to find the resultant area? This resultant total surface area. Okay, now this total resultant area is nothing but CSA of cone plus 2 into 2 into CSA of hemisphere. Hemisphere will get the required solid surface area. So what is CSA of sorry, it is cylinder, no? This is cylinder. CSA of cylinder. Cylinder plus 2 into CSA of hemisphere. So it is 2 pi r h plus 2 times of 2 pi r square. So we'll get it is 2 pi r h plus 4 pi r square. So we can take it 2 pi r common and we can substitute the required what the values are given in the problem. We'll get the answer. Next combination figure. Yes, see, this is a combination of hemisphere and cone. Hemisphere and cone. The totally one new toy, like a new solid will be formed. This is the new solid. So we know that in case of the new solid, how to find its total surface area means CSA of hemisphere plus CSA of cone. Okay, now. So we know that CSA of hemisphere cone will be how much? Cone out of CSA is pi RL. Hemisphere CSA. Hemisphere CSA will be 2 pi r square. So together we can add up, we'll get your total set pi RL plus 2 pi r square. Again, we can substitute the given values and we can take, first of all, we can observe here carefully the pi r will be common. We can take out the pi r will be common. Then we can substitute the values and we can calculate. We'll get easily this solid combination of the solid area. Next, one more combination, very important one here. So in this combination, a cube surmounted by here one hemisphere will be there. So what is the result again? This one area, the resulted area. This area will be no, I'll check it. TSA of cube plus CSA of hemisphere minus base area of hemisphere. So now substitute the formulas. TSA of cube 6a square plus CSA of hemisphere 2 pi r square and minus base area of the hemisphere is a circle, it is a pi r square. So we'll get 6a square, 2 pi r square minus pi r square will be pi r square and we can substitute the values. Here the diameter, here one point, see here. The diameter of the hemisphere is nothing but side of the cube only. We'll get easy answer. Next combination. Uh, the surface area of the combinations are same. Cylinder, hemisphere. Cylinder, hemisphere. Now we can say the formula yourself. We can say yes. Cylinder CSA. CSA of cylinder plus CSA of hemisphere. Yes, this is the correct. Substitute the formulas now. 2 pi r h plus 2 pi r square. Okay, clear? Yes. Next one. It is another one. So two cubes adjacently they join. Then we'll get the new shape will be cuboid. The new shape is cuboid. Now the cuboid length is how much? The length of the cuboid will be 2a and the breadth will be a, h will be a. So by using these measurements, we can calculate the required TSA. So TSA of the cuboid will be, what is the TSA of cuboid formula? 2 times of LB plus BH plus LH. Next combination is cylinder and hemisphere combination. So what is the total surface? Same CSA of cylinder. I think you will understood everything now. Plus CSA of hemisphere. CSA of hemisphere. So 2 pi r h plus 2 pi r square. The same thing. Next combination. Almost all models we covered in this video. So here also same procedure. If it is depression also, the shape will be this curved area we need to add. This area we need to add. The same thing. TSA of cube plus CSA of hemisphere minus base area. Base area of hemisphere. We will get the resultant solid area. Next, this one. Conical tent surmounted by a cylinder. Tent surmounted by a cylinder. Same procedure without a total surface area. In this total surface area, CSA of cylinder plus CSA of cone. So what are the formula? CSA of cylinder will be 2 pi r h plus pi rl. Pi rl. Pi rl. Next. Yes, there is some conical cavity they given this remove this one, so we need to calculate this area and this one area and the area of the base and inner this area inside this area. So it is nothing but CSA of cylinder plus CSA of cone plus base area. Base area. For example, if you have a doubt in this problem, means just we can imagine I want to paint this one. I want to paint this one. So the cylindrical shape I need to paint, and inside this cone also I want to paint. Inside this conical shape, this area also I need to paint, and the base I need to paint. So that's why CSA of cylinder plus cone plus the base area. So we'll get the answer. So what are the formulas here? 2 pi r h plus pi r l plus pi r square plus pi r square. And also volumes. Volumes. Volumes means it is very easy. So what we are going to calculate is given. For example, it is a cylinder. They scooped with two hemispheres. So we can do it. Cylinder. See a volume of cylinder minus 2 into volume of hemisphere. 2 into volume of hemisphere. Two hemispherical ends their depression. No? So you can do it by using this formula, we will get the answer. Next, here also same thing. Cylinder hemisphere. Cylinder hemisphere. So volume of cylinder minus volume of hemisphere. Volume of hemisphere. The formula is, what is the formula? Pi r square h minus 2 by 3 pi r. Substitute the common variables and we can substitute the value. We'll get the answer. Next one. Volume of cylinder, the both end attached with the cone. So what is the resultant volume? All the three we can do it like volume of cone, volume of cone plus here two cones will be there. So we can write 2 into volume of cone plus volume of cylinder. Volume of cylinder. So that is nothing but 2 into 1/3 of pi r square h plus pi r square h. We'll get the resultant. Next, the pen stand they given. So what is the remaining? The stand is it is in the shape of cuboid, and the holes is the conical shape. Conical shape. What is the remaining area? So what we need to do? Volume of cuboid minus how many holes will be there? Four holes are there. 4 into volume of cone. We'll get the resultant area. So almost we completed everything. So just we can recall one more time all the formulas. Just recall all formula and we can start exercise problem. That's it. All the models we covered. Okay, thank you.